Do you remember what we learned in our last session? Absolutely correct. We learned how to make a linear equation with one variable. Children, in this session, let's see how to solve linear equations with one variable. Look at this equation. We saw this equation in our last session. Now, let us try to find the value of x in this equation. We can think of an equation as a weighing balance. If the weight on both sides of the scale are the same, then the two sides are in balance. An equation is like this. The value of the expression on the left-hand side is balanced exactly with the value of the expression on the right-hand side. Think of numbers as weights. So our task is to find the value of x such that the balance of the equation is not disturbed. Can you think of a way to find the value of x? The procedure is to write only x in place of all these digits on the left-hand side. And, doing so, we have to remove something from the right-hand side in order to maintain the balance. If we succeed, then the value of x will be the number on the right-hand side. This is where thinking of an equation as a weighing balance helps us. We know if we add some weight on one side, then to keep the two sides in balance, we have to add the same weight on the other side. Similarly, if we remove some weight from one side, we have to remove the same weight from the other side as well. Similarly, in our equation, we can perform 4 operations. They are addition, subtraction, multiplication, and division. So if we add a number on one side of the equation, then we have to add the same number on the other side. Similarly, if we subtract, multiply, or divide, we have to do it on both sides. Now let's solve this equation. First, we can see it's easy to remove 50 from here. So, we subtract 50 from both sides. Now the equation becomes like this. What we get is 3 times x is equal to 30. So what should our next step be? Yes, we need to get rid of this 3. As 3 is being multiplied by x, we can get rid of 3 by dividing the term by 3. But then, we have to divide by 3 on the right-hand side also. Now 3 and 3 cancel each other on the left. And on the right-hand side, we can divide 30 by 3 to get 10. So ultimately, we get the value of x as 10. So in this session, we have learned how to solve the linear equation with one variable. In the next video, we will look at some more examples to understand how to solve such equations. Friends, in our last session, we saw how to solve a linear equation with one variable. Now in this session, with the help of some examples, we will understand how to solve these linear equations more efficiently. Consider this situation. Raghu gets a rectangular-shaped parcel from the delivery man. He wants to measure the parcel to guess the contents of the parcel. He has a 5 centimeter long scale that he uses to measure the parcel. He finds that the width of the parcel is exactly 5 centimeters, but the length is somewhat longer than 5 centimeters. His ruler falls short while measuring the length of the parcel. He also notices that in small letters, the area of the rectangular shaped parcel has been measured to be 45 square centimeters. Can you help Raghu find the length of the parcel? Let's help him. We know that the breadth of the parcel is 5 centimeters and the length of the parcel is longer than 5 centimeters. So, we can write the parcel's length as 5 plus b centimeters. We also know that the area of the parcel is equal to 45 centimeters square. We know that the area of a rectangle is length times its breadth. So, we can form an equation with its area like this. Here, we will have to solve this equation to get the value of the variable b. So let's go ahead with our equation. This is how we can expand our equation. Now, we will have to subtract 25 from both the sides so that we can eliminate 25 from the left-hand side of the equation. On doing so, we get this new equation. But look at these steps carefully. Let's say from our equation, instead of subtracting 25 from both sides, can we directly transpose 25 from the left to the right-hand side? Yes, we can do that. When we do that, we see that this equation is the same as the equation we got by subtracting 25 from both sides. But an important thing to notice is that when we transpose 25, we change its sign. That means from plus 25, it becomes minus 25 as we transfer it. Now, we will divide both sides of the equation by 5 to get the value of b. On doing so, we see that the value of b turns out to be 4. Now, we know the length of the parcel is equal to 5 plus b. So that means the length of the parcel is 5 plus 4, which is 9 centimeters. Now let's solve one more simple problem. Can you tell me what will our first step be? Yes, we will transpose the number minus 5 to the right-hand side. But be careful. When we transpose minus 5 to the other side, it will become plus 5. After this step, we will get the value of x as 15. As you can see, we got our solution in just one step by transposing minus 5 to the other side. So this efficient way will help us in further sessions to solve the equations swiftly. To conclude, in this session, we saw that we can solve linear equations in one variable very easily and efficiently by transposing numbers to the other side. But always remember that while we transfer a number, we change its sign. If a number is a positive number on one side, after transferring, it becomes negative. And if a number is negative on one side, it becomes positive on moving to the other side. This means addition becomes subtraction and subtraction becomes addition. In the next video, we will look at some misconceptions that arise while solving linear equations in one variable. In our previous session, we saw how to solve linear equations with one variable. Friends, in this session, we will take a look at some common mistakes related to its concept. Suppose this equation is given to us, and we have to find the value of x. The options given to us are as displayed. What do you think is the right answer? The correct answer for this question, option B, that is, x is equal to 2. Now, some of you might have got option A as the answer. Why do you think this happened? Where did you go wrong? Let's find out. The equation that we have is this. Since 8 is multiplied with this term, we simplify this by opening the bracket. But this is where we need to be careful. Because while multiplying by 8, we tend to multiply only 4x by 8 and forget to multiply 3 by 8 as well. This is why we end up getting the wrong answer. If we look carefully, we can see that the entire bracket containing this expression is multiplied with 8 and not just 4x. Thus, along with 4x, we must also multiply minus 3 with 8. So our second step must look like this. Thus, when a number is multiplied with more than one term within a bracket, we should be careful to ensure that the number is multiplied with all the terms inside the bracket. Now we know how to solve this equation. If we solve this equation, we will get the answer to be x is equal to 2. In today's session, we saw common mistakes related to solving linear equations with one variable.
In the previous sessions, we learned to solve linear equations in one variable. Note that in all these equations, the variable is only on one side. So friends, in this session, we will solve linear equations in one variable where the variable is present on both sides of the equation. Let's understand this with the help of an example. Rani has been given 2 square chart papers. The length of the bigger paper is 5 inches more than that of the smaller paper. She has to find the length of the smaller paper. The clue has been given to her. The clue is that the perimeter of the bigger paper is 4 by 3 times the perimeter of the smaller paper. Let's find out the answer. We have been told that the length of the bigger paper is 5 inches more than that of the smaller paper. So, if we use L as the variable of length of smaller paper, then the length of bigger paper will be equal to L plus 5. Let's use the clue given to Rani. The perimeter of the bigger paper is 4 by 3 times the perimeter of the smaller paper. We can write it this way. Did you notice it? Here, the variable exists on both the sides of the equation. Till now, we have always solved problems where the variable has been only on one side of the equation. But don't worry. Let us now resolve it together. Now, if we expand these brackets here, we get this equation. Now, to get rid of 3, we shall multiply both sides with 3. Since we want the variable L to be only on one side of the equation, we must shift this expression to the right-hand side. When we do that, we will have to subtract 12L from 16L. Can we subtract 12L from 16L? Yes, we can do that. The common variable in both expressions is L. We have read in the previous grades that such terms are called like terms. And we can either add or subtract them. So when we move 12L to the right side of the equation, we can subtract it from 16L because they are like terms. Now we get an equation of a known form. Finally, we got the variables on one side and constants on the other. To find the value of L, let's divide both sides by 4. Finally, we get the value of L as 15. So, the length of the smaller paper is 15 inches. We shall end this session here. We learned that linear equations with one variable can be solved even when the variable exists on both sides. In the next lesson, we shall see other examples of linear equations. In the previous session, we learned that a linear equation with one variable can also be solved when there are variables on both sides of the equation. So friends, today let's look at another interesting example and learn solving such an equation. Raghu had a 12-inch candle, while Rani had an 18-inch candle. Both of them lit their candles at 6 a.m. Raghu's candle decreases upon burning ½ inch every hour, while Rani's candle decreases by 2 inches every hour. We have to find how much time will it take for both the candles to come to the same height. Come on, let's start solving this problem. We have been told that Raghu's candle is 12 inches long. The candle is burning at a speed of ½ inch per hour, which means that in 1 hour it will burn ½ inch. In 2 hours it will burn 1 inch, and in 3 hours it will burn 1½ inch. Therefore, we can say that in each hour the candle will burn 1/2 times. Initially, Raghu's candle was 12 inches in length. So, we can say that after each hour, the length of the candle will be 12 inch minus 1/2 times each inch. The same method will also apply to Rani's candle. We know that Rani's candle was 18 inches in length. It is burning at a speed of 2 inches per hour. So we can say that in 8 hours, Rani's candle will burn 2 times each inch. Since the initial length of Rani's candle is 18 inches, therefore, the length of Rani's candle after 8 hours will be 18 inch minus 2 each inch. Now we have an expression for the length of the candles for both Raghu and Rani after h hours. Further, we must find the value of h for which both candles will have the same length. Thus, the values of the two expressions will be the same. So this is our linear equation in h variable. But again, there are variables on both sides of the equation. Let us now put the terms with the variable h to the left of the equation and move all the constants to the right side of the equation. So, when we replace the negative 2h and put it to the left, it will become positive 2h. Next, we must move 12 to the right side of the equation. So, the positive 12 that has been moved to the right will become the negative 12. Now, after subtracting these two terms, we will get this equation. Since 3/2 is multiplied by h, we must remove 2 from the denominator and multiply both sides of the equation by 2. Now we shall divide both sides of the equation by 3 to remove the 3 with variable h. The value of h is found as 4, which explains that after 4 hours, both the candles will be of equal height. Since the candles were lit at 6 a.m., they would be of equal length at 10 a.m. With the help of an interesting example, we learned linear equation in one variable where the variable is present on both sides of the equation. In the next session, we shall look at some misconceptions related to this concept. Friends, in the previous session, we solved examples of linear equations in one variable. Kindly make a note that the variable is on both the sides of the equation. In this session, we shall look into few misconceptions that can occur while solving such equations. Look at this expression. Out of these two options, which option would be the result of this expression? Let us first have a look at option A. We know that the figure 7p is actually 7 times p. Similarly, here p can be written as 1p. So in this expression, we can easily apply the distribution property. When we do this, we can consider p being always present and write its coefficient as 7 minus 1. So, the correct answer would be 7 minus 1 multiplied by p minus 7, which is 6p minus 7. Because there is no other number in the expression, 7 will remain as it is. Hence, the correct option is A. At times, 7 is considered to be common, resulting in subtracting p from p, which leads us to option B. But that is the wrong option. Let's look at another question. When do you think this statement will be correct? Can we consider A as the answer since h is a variable? This shows that the value of h can vary, isn't it? So, if h is equal to 7 on this side and 0 on this side, then this statement can sometimes be false. But this notion is wrong. Do you know why? In spite of h being a variable, it does not mean that it will have different values in the same situation. Therefore, h cannot have two different values simultaneously. Here, h indicates an unknown number. So the value of h is the same number, but we do not know what it is. Based on the same assumption, if we place the same number in place of h on both sides, we shall see that this statement will always be true. So the correct option is B. In this session, we dealt with two similar misconceptions where one can easily get confused while trying to understand the concept of linear equations in one variable.